Welcome students. Today we're going to do a review of dividing exponents. Example 1. X to the third, y to the fourth, z squared over x to the fifth, y squared z. Just like we did with multiplication, we are going to expand out each expression. X to the third is just x times itself 3 times. Y to the fourth is y times itself 4 times. And z squared is z times z. These are all on top of the fraction. On the bottom, I have x to the fifth, x times itself 5 times, y squared, y times itself twice, and z. Now, I need to go through and I need to figure out what cancels. From top to bottom, if I see a pair, I can cancel one of each. So for instance, as I look at my x's, I have 3 x's on top. They can cancel with each of one of the x's on the bottom. That will leave me 2 x's down below. Now as I look at my y's, I can cancel 2 pair of y's and leave 2 y's on top. And z's, I can cancel just 1 pair and leave 1 z on top. Now, I circled my remaining values. I need to convert these back into a simplified base and power, and then I need to make sure I get them on the right portion of the fraction bar. So I'll draw my line. If I had them left remaining on top, this is where they will stay. So my 2 y's, y times y, will become y squared, and I will make sure to put that back on top where it came from. This has now been taken care of. My z is also left, and that is just 1z or z to the first. You can have the exponent or you can leave it out. It does not matter. Now I'll look at my x's. X times x is down below. That is the same as x squared, and this would be my simplified answer. I want you to pause the video, try B on your own, and unpause when you're ready to check. To expand it out, you should have expanded out a to the third as a times a times a, times b times c to the fourth, so 4 c's. Should have put your clear fraction bar, and down below, expanded out a to the fourth, a times itself 4 times, b squared, b times itself twice, and c to the sixth, c times itself 6 times. Now we're going to look for what we can make cancel. I can make 3 pairs of a's cancel, which will leave 1 a down below. I can cancel 1 pair of b's, which will leave 1 b down below. And I can cancel 4 sets of c's, which leaves 2 c's down below. If you notice, everything across the whole top has been canceled now. If my entire portion of a fraction bar is canceled, I'll replace that with just a 1. Now I'll put my values down below. I have 1a, so that's just a. I have 1b, so that's just b. And I have 2 c's, so that is c squared. And this would be my final simplified answer. Example 2. When I have coefficients, it gets a little bit trickier. I need to deal with those front numbers as well as with my power and bases. Again, I'll start by expanding it out. So a, I would expand out to be 4 times a times b times b times b times c. And that will all be over 6 a to the fourth, so a times itself 4 times b times c times itself 3 times. Now I'll look for anything I can get to cancel. I can cancel 1 set of c's, 1 set of b's, and 2 sets of a's. This leaves 2 a's down below and 2 c's down below and 2 b's up top. I also need to look at my coefficients 4 over 6. These I will simplify just like a regular fraction. Notice 4 over 6 is just two even numbers, which means I could cut both in half. That would give me 2 over 3. At this point, I can't simplify 2/3 any further, so I would put 2 on top and 3 on the bottom. And now I'll fill in my expressions from before. So 2 b's were left up top, so that would give me a b squared. 2 a's were left down below, so that's a squared down below and c squared down below. And this would be my final simplified answer. I want you to try example B on your own, pause the video, and unpause when you're ready to check it. Again, I would expand out, so 6 times x times y to the third power times z over 2 times x squared times y times z. Now I'll look for anything I can cancel. Notice I can cancel 1 set of x, 1 set of y, and 1 set of z. That leaves me 2 y's on top, 1 x down below, and a fraction I still need to simplify. 6 over 2, if I think about that as a fraction, is just going to equal 3 over 1. Again, they could both be divided by 2. So I'll put 3 on top and 1 down below, and then I'll fill in my variables where they go. The y's will come to the top, because that's where they were left, so y squared, and the x will fill in down below. This should have been your final answer. Notice your z's completely canceled, which means I did not have to write them in my final answer. So 3y squared over 1x is what you should have found. Thanks for watching.